Okay, so the important info for today is next week is the last day of the 9 weeks. Or no, next week is the last week of the 9 weeks. That we only have one class left because next week on Friday, it's a half day, so we won't have a class next Friday. We only have a class on Tuesday. So we'll have Tuesday's class, and that's the last class of this 9 weeks. Now, why that's important is because this is not a semester class. This is a 1/4 class, which means by next week, whatever grade you have in the grade book by Friday, that is your grade in the report card for this 9 weeks. It does not get averaged in to the next class, which is mobile apps. And most of you are in mobile apps next quarter. That's a completely separate class, completely different grade. So it's not a semester class like most of your classes are. It's only 1/4. And so that's your grade. If you fail this class, which I only have 2 people, I think, in this class who are failing, and one of them I've never seen in this class. And the other, let me see if he's here. The other is here. The other one person logs in but then leaves. He's not here today. And then I have one person that has I think one person has a D. 2 people have a D, which that's okay. You can survive a D, but you cannot survive an E because you have to repeat the class. So if you're missing assignments, if you're late on something, you need help turning something in, let me know and I will find a way to make you pass. If you make an effort to, I'll find a way to make you pass. But like I said, my failing people aren't even here anyway. So, and my D's are here, but you guys are okay. You're not that bad. All right, so enough of the important info for today. Let's see. Today, what we're doing, let me stop presenting for a second. Today, what we're doing, what I did is I picked up an Arduino. I'm going to show you here. Let me pull my screen up so I can see myself. Make sure I'm showing it to you. Okay, so this is a real live Arduino. So right now we've been playing with the simulator. Well, this is what the real one looks like. And right there I have a breadboard here, right here as well. I got a bunch of LEDs on there, and they're all hooked up there. You can see I've got my negative wire going to the negative rail. I got all my pins, everything in there. Now you see how those LEDs are moving? And they're moving up and down, or back and forth, back and forth. That's the project we're going to do today. So we're going to build that circuit today. And it's the exact same circuit that's on this Arduino here right now. So let's go ahead and jump into that. What we've got in Google Classroom, let me share my screen again. Okay, so you can see what I got here. Google Classroom. Here we are. We have a new assignment. It's called For Loops in the Knight Rider project. If you've ever heard of the TV show Knight Rider, where they had that car, and the car had the red light on the front and moved back and forth, just like that light that I just showed you. That's why I'm calling it the Knight Rider project. So we're going to do 4 loops. So inside here in this assignment, first thing we're going to do is we're going to go through this presentation on 4 loops. Because we're short a class this week, since we didn't have a class on Tuesday, I went ahead and I made the code for you here in Knight Rider code. So we're going to copy that into Tinkercad later on. But it's the one right here that says Knight Rider code. And I made most of it for you, except there are some small things that we're going to change to it. Then once you're done, you're going to copy the finished code over into this code document right here, and that's what you're going to turn in. To get into Tinkercad, we're going to use this link right here to make sure that we get logged in the right way. Okay, so right now, the 4 loops presentation, let's take a look at that. And present, and let me get my pointer going on here. Pointer, okay, before we jump into that, let's take a look at some spot the errors. Anybody take a look at that and tell me what are my errors in my code? You can put it in the chat or you can unmute yourself if you want. Oh, yes, Alina, perfect. So this one right here, these parentheses, they're supposed to be curly brackets. I've noticed several people have made that mistake. They use the parentheses here. These have to be curly brackets. Curly brackets are everywhere that we're doing some line of code or executing some commands. If it's parentheses, it usually means we're passing parameters. So that's one mistake. There's another mistake there. There's actually two more mistakes. One of them is kind of tricky. No, this one has two easy mistakes. It's on the same line of code. Input, it doesn't have to. I mean, you could, this particular code, this is a blinking LED code. So it makes pin 13 as an output. It sets it to high, delays, sets it to low, delays. So it's just a simple blinking LED. So you wouldn't need to have an input for that. I mean, you could put one on there, but you wouldn't need one. That's just telling me that I'm using pin 13 as an output. The mistake we're looking for is right up here at the top. This integer here, first, it has to have a lowercase I. We can't use an uppercase. It's got to be int lowercase. Second one, it should have a semicolon at the end. All right, so next one. This one's a little harder to spot. What do you think this one is? It's got a couple of errors in there. One that's kind of a really tricky error, and it's got one easy error. And some people, like every class that's looked at this so far has said, they've said the ln, that I don't have ln. You don't have to have ln there. Ln just means line. So I'm printing, you can just print and it doesn't make a new line, or you can print it and then send it to a new line. So only thing this does is it keeps the first thing keeps these two things on the same line. Anybody else see the error? Should the capital M be lowercase? Ooh, yes, that is it. That is it, Ella. And I missed that one. Actually, I forgot to tell the last class that one. Yeah, this has a capital M. Because up here, I declared my variable with a lowercase, and I put an uppercase here. So that should be lowercase. And then Molly says semicolon after the 9600. That's correct. Should be there. There's actually one more error. I totally forgot about the one that Ella said. Yeah, there's that one. There's one more error that's hard to spot because it's not an omission. It's actually a code that's in the wrong spot. And it relates to what Ella was talking about. Nope, that delay, I think, that delay is fine. The period, the one under here, no, that one's fine. Because what it's doing, anytime you put quotes, it's going to print out whatever is exactly in those quotes. So you can put whatever you want. So in this case, what I did is I have a space and I say U period. So what would actually print, if this was correct, it would say my words, which is hello. So it would actually print hello space U period. But actually, it wouldn't print that because here's the mistake. This string that I've declared up here, this is inside the setup function, which makes it a local variable that can only be used inside a function, inside setup. It can't be used in here. So we actually, to get this to work, we would have to take this variable and make it a global variable by putting it outside the setup function, or we could put it as a local variable inside the loop function. So that was it's kind of a tricky error that is tough to spot because you're not missing anything. Okay, so moving on. Today, we're talking about for loops in a computer program. We're going to write a basic program using some for loops, and we will be successful when we have done that. So what is a for loop? A for loop specifies iteration. And iteration is a word that means a certain number of repetitions. So for one iteration or two iterations or 5 iterations basically means I'm doing something for 1 time or 5 times or whatever. So when we're doing a for loop, we're doing something for a certain number of times, and we're counting how many times we're doing it. So before we get into that, let's look at some computer math, because there's a couple new things in here that we're going to need to use. Now we know about less than, more than. We've talked about this double equal sign here. We know about add, subtract, multiply, divide. The two new ones are increment and decrement. And we write those with plus plus or minus minus. So plus plus, if we write something, say we have a variable and we say variable x or whatever, if we'll say x is equal to 1, and then we say, okay, now do x plus plus. What that means is we're doing whatever x was, so 1 in our case, plus 1. So x plus plus would be 2. Decrement is the exact opposite. When we do minus minus, we would write it as x minus minus, and then that would subtract 1 from whatever value x is. The last thing I just threw on there, it's not that important, I just put that on there because it's one that I like. It's called modulus. And what the modulus is it returns the remainder after you divide two numbers. So if you divide 2 into 3, rather than giving you like point whatever, the remainder will be 1, right? So it would return 1. So if you said modulus or 3 modulus 2, the answer would be 1. It tells you how much is left over. And that's sometimes used like on programs if you want to tell what even numbers from odd numbers, because if you can divide an even number by 2, then it's not going to have a remainder. But if you divide an odd number by 2, there's going to be a remainder, which means it's an odd number, and so that way the computer can tell the difference between the two. Okay, so for loops, this is what they look like. First thing we have is we have for, then we have our parentheses that are doing our conditions and parameters and such. Then we have our curly braces. Then we have the block of code, whatever it is that we're going to be executing is going to be right there. So this first statement, we have every for loop has 3 statements in it. The first statement, and they're all separated by semicolons. Pay attention to that because I messed that up earlier this week and I was using commas, because some languages I think use commas, but this one uses semicolons. And I had it all messed up earlier and I couldn't figure out why. But so the first statement is executed 1 time. So when you go through the for loop, the very first thing it does is it does statement number 1. Then it goes to statement number 2, and this is the kind of like an if statement. It's the condition for executing. If the statement is true, then it executes what's in the code down here. Then after it executes the code, it comes up to this third statement, and every single time that the code is executed, then it does this statement here. This is where we have the plus plus or the minus minus. This is the increment or the decrement. So it's going to take whatever's in statement 1, which we'll see. I'll walk you through it in a second, and then it's going to increment it by 1 or decrement it by 1 or 2 or 3 or 4 or whatever you put in there. So, but it has to have those 3 statements, and then you have a block of code that's executed down here. Okay, so here are the parts with stuff in them, real things. So the first thing is I do an integer. And now this is important too, because I messed this one up earlier today. I forgot to put int, and I just put like count equals 0, and it doesn't work that. You've got to put int in here. So I'm doing integer, I'm doing a variable called count, and it gets the value 0. So that's the very first thing that happens, is it says, okay, count is equal to 0. Then it does the test condition. It says, okay, actually, wait, I'm not going to go, I'll tell you that in a second. Let me just go, just know that that's what it looks like, because I want to go through all these individually in a second. But that's the test condition. And then this is the increment, count plus plus. And then my code I'm executing down here, anybody know what this line of code would do? You can unmute yourself or put yourself in the chat, what that line of code does. What does that line of code right there do? Put it in the chat. Prints the serial code. It prints whatever's in here. Yeah, it prints to the serial monitor. It's going to print whatever is in here. And in this case, it's count. And it's the variable count. It's whatever this number is here. So right now, count is 0. So it's going to print 0. Now, if I wanted to print, somebody earlier said it prints the word count. No, it only prints the word if you have quotation marks. If there are no quotation marks, it's going to think that's a variable. So it's actually going to print 0. Okay, so here's what it looks like. First, I have my variable, and it's an integer. It's called count. It gets the value 0. Second, it goes here and it says, okay, is count less than 5? And it's going to be a true or false question, a Boolean question. And it says, is count less than 5? That is true. Count is less than 5. I know that with all my math skills. I can tell that. And then it's going to say, okay, if that's true, then we're going to do this line of code, which is going to print the value of count, which in our case right now is 0. So it prints 0 on the screen, or actually in the serial monitor, like Andrew said. It's going to print 0. Then it's going to come up here, and it's going to say, okay, do count plus plus. So count right now is 0. So it's going to go 0 plus 1. 0 plus 1 is 1. So now count is 1. Then it's going to come back to here, and it's going to say, okay, is count, it's 1 now, is 1 still less than 5? And the answer, that's true. So it's going to do this again, and it's going to print count. But the value count is now equal to 1. So now it printed 0 last time. Now it's going to print a 1, and then it's going to increase count by 1 again. So now 1 plus 1 is 2, and now it's going to print out, it'll print count again, and now it prints 2. But it'll keep on doing that until count gets to 5. And then it's going to say, is 5 less than 5? Is that true or false? You can put it in the chat. True or false? 5 is less than 5. That is false, Amaya says, and that is correct. 5 is not, it's not less than 5. It's the same as 5. So it would stop, and it wouldn't print 5. So what that would look like, and then this place here, I just replaced count with X. It would print 0 first in the serial monitor, then it would print 1, then it would print 2, then it would print 3, then it would print 4. So that's what a for loop does. Real simple. We're going to use it today in that flashing light project that I showed you. That's like the Knight Rider car. On the Knight Rider car, those lights in the front, they move back and forth, just like that circuit that I showed you earlier. And that's what we're going to do today. So any questions on for loops? No questions, Ramsey says. Okay, so we're done with that. Now, to speed things up a little bit today, just because we're kind of short on our class time, I went ahead and put the Knight Rider code here. So this is basically all the code. The only thing I did was, let me zoom that up a little bit. Only thing I did is in the statements, I just put statement 1, 2, 3, and then variables. Pay attention to this because we're going to be looking at these variables, and we need to make sure we change that. So everything that's in red has to be changed, but when we paste it over to Tinkercad, it's not going to keep it in red. It'll turn it back to black, and it's hard to see. But just pay attention that what you're going to have to change are the 3 statements inside of each for loop, and then the variable that's used in the for loop. So what we're going to do next is you're going to go over to Tinkercad. You can click on the link inside the text. My sound is gone. Uh-oh, Ramsey. Can anybody else still hear me? Amaya says she can hear me. Malcolm can, Anthony can. Okay, so it's not me. Ramsey, who said that? Let me see. My sound is going. Ramsey, try to refresh your browser, Ramsey. Okay, so try to refresh, reboot your, but you can't hear me say that, so I typed it in the chat for you. Hopefully you see that. Okay, so, yep, he left, he'll come back, let's see. All right, so then we're gonna click on this link here, and it's gonna take us to the sign-in part for Tinkercad. Yours is gonna be your first name, last initial, all one word, no space. Okay, good, Ramsey. All one word, no space, and then say that's me. It's going to take you to your dashboard. So I think we've done something in the dashboard before, if I recall. And once we're in the dashboard, we're going to go over to the side here where it says circuits. Now I'm going to kind of try to go a little fast, just because I feel like I want to get this done. But if I'm going too fast, then just tell me in the chat to slow down. So, or you can unmute yourself and say, slow down. So I'm going to click on circuits, and I can see all the circuits that I've done. And you can see I've been doing Knight Rider all day today and yesterday, or Monday, I should say. Oh, no, today and Monday and yesterday. There it is. And what we're going to do is we're going to create a new circuit. So if we create a new circuit, it's going to take us here, and it's going to be completely blank. Completely blank. And we're going to try, I want to have you guys do this by yourselves as best you can, but we're going to be basically building the LED circuit that we've done a few times already. So I'm going to go through quickly. What I'm doing is I'm just going to take an Arduino and a breadboard, and I'm going to go grab 6 LEDs. I'm just going to plug 6 LEDs in. Same thing we've done before. I'm going to try to go a little fast, but if I go too fast, then tell me to slow down. 1, 2, 3, 4, 5, 6 LEDs. Remember, we need resistors on all of them, and I'm going to connect them on the cathode side, going to my negative rail. And these are going to be 220 ohm resistors, which I'll change that in a second. But so let me zoom in so you can make sure you see I'm putting them on from the cathode side to the negative rail. Cathode side to negative rail. And now they all need to be 220 ohms. So just like before, I'm going to change that to 220. Use my drop down to change it to ohms from kilo ohms. And every now and then I've noticed that I'll have like the box disappears on me. But if you just click another resistor, usually it brings it back. Let me know if I'm going too fast or you're having problems in the chat. Okay. So now the next thing is there's a couple ways you can do this. I want to put the negative rail to the ground. My screen zoomed in like a lot, and I don't know how to fix it. Is it this one you're talking about right here, Ella? Like doing like this, it's like that. What I'm zooming is I'm using my wheel on my mouse, the middle scroll wheel. If you're using a Chromebook, I'm guessing, I think what happens on the Chromebooks is the scroll wheel is on the right side of the touchpad. So my guess is you probably accidentally touched the right side of the touchpad, and that automatically might automatically zoom. Okay, good. All right, Ella's good. All right, so what I'm going to do now is this negative rail, I'm going to connect to the ground. So you can use this one, or you can use the one on the other side. They all go to the same place. It doesn't matter. So I'm just going to do a little wire here. I'm going to come out. It doesn't matter where you go on the rail, remember, because they're all connected. So just put that little in there. And then the next thing I want to do is I want to connect, and actually what I may do, I want to slide this down. Ooh, I just accidentally clicked there. Don't do that. Okay, well, I'm going to slide that down there. It might make it easier to connect my wires. I'm going to straighten these out just to be pretty. All right, so next thing, I'm going to take the anode side of my LEDs, so right here on that side, and I want to go to the pins, and I'm going to use pins 2 through, I think it'll be 2 through 7 or 2 through 8, whatever. So I want to go right here, cathode, or sorry, my anode side. Wait, what's the number? Number for the resistor is 220 ohms. 220 ohms. And I'll let you get caught up there. I think we're okay on time right now. But the next thing I'm doing is I'm connecting my anodes to pins 2 through 8, I guess, whatever that is. So 2. I'm not going to do this pretty. I'm just going to go like that. 5, 6, 7. No, 2 through 7. Okay. So my resistors are going to my negative rail. I got a wire going to the ground. I got resistors going to cathodes on each of the LEDs, and I've got a wire going from the anode side to pins 2 through 7. Okay, now, once you get that, we're going to go to the code and go to the text code. And you can delete everything that's there. You can just delete the whole thing. And if you go into that code that I gave you, you can just go ahead and copy that in there. And then Control C and Control V, or you can right click and paste it in there. Now I'm going to get rid of my 2 comments that I put up here, the 2 comment lines. And now you can see, unfortunately, all the text that was red that we have to change is now back to plain old regular. And what I'm going to do, I'm going to zoom in my screen a little bit, so I hope you can see that a little better. Hopefully. All right. Everybody caught up there to get the code pasted in there? Anybody who's struggling right now? Having internet problems? Oh, yeah, that's what I thought. Yeah, Alina, that the last couple of days, it seems like the internet has been slow. Can you go out of the code for a minute? Yes. Let me, so you want to look at the circuit? I'm going to have to, oh yeah, there we go. Oops, come back. So can you see it? Is that good right there? Close enough for you? So what I did is I just had 6 LEDs. They're all plugged into just the top, to row E, or column E, whatever that is, depending on which way you look at it. And then, does it matter which number the resistors are? Yeah, I mean, I put 220 ohms, and the only thing it will affect is how bright the LED is. So I did 220 ohms. So if I click on there, you can see I got 220, and then I got the ohm sign. No, where it is on the breadboard, no. The only thing that matters is that I'm going from the cathode here to the negative rail. So you got to make sure that you get 1 in the negative rail. It doesn't matter what number, or it'll actually end up being in column B, just because that's the way they fit. That's how long they are. I deleted everything and copied the other code. What did I do? In here? Oh, yeah. Oh, in that. I thought, yeah. Then what I did is, in the code, everything that was there, I just deleted the whole thing. So it was blank, like that. And then I went over to this document, selected all of it, copied it, and then pasted it. And then and what I did, you don't have to. I deleted the comments just because those kind of comment, for some reason, when you're coding, you're supposed to use comments to explain what your code is doing, but for some reason they seem to distract me. So sometimes I usually delete them until I get all the way done, and then if I need to put a comment, I'll put a comment in. But a lot of times the comments distract me with all that text, so I delete them. Now, so let's take a look at this code. The first thing I did, I have a global variable that is an integer called timer, and I set it to 100. And this is what I'm going to use for my delay. So later on, you'll see it's actually going to become milliseconds when it goes into the delay. Now, in this part here, in the void setup, I'm using a for loop. Normally, what we would do is, if you'll recall, we use pin mode, and we would say pin mode 2 output, pin mode 3 output, pin mode 4 output, pin mode 5 output. But instead of doing all that stuff, we can just use a for loop, and it will go through each pin and set it to an output automatically. So the way I would do that is in my for loop, in these statements here, my first statement is going to be what pin that I want to change. So my very first statement I'm going to say is an int. You got to put int in there. I almost forgot to put int. You got to say int. I'm saying pin equal to 2. And I did that because 2 is the first pin I use. So like down here, you can see the first pin I used was pin 2, which is the first one that we can use as an output. So in my for loop, my first statement, statement 1, I say int pin is equal to 2. Now, if I look, my last pin that I used is 7. Okay, so this is where I want to make sure that I stop my loop after it does 7. So the way I would do that is I would say pin is less than 8, because 8 is 1 more than 7, and I don't want it to get, I don't want to say 7, because then it will say 7 less than 7, false, and it won't actually set up pin 7. It'll skip pin 7. So I want to go one more and say pin is less than 8, because I want it to keep doing this until my value pin, my variable pin, is less than 8. Or not until, sorry. Keep doing it while pin is less than 8, I should say. And then the last thing I'm doing down here in statement 3 is I'm going pin plus plus. So pin plus plus. And that's the instructions part of my for loop right there. Now, the one other thing I need to change here is variable. Okay, and in my case, I used pin as my variable. I could use that same variable here because that's actually the pin number that I want to set. So if I just say, instead of variable, I type pin, and what it will do is the first time through, pin is going to be equal to 2. So it's going to say, okay, pin 2 is an output. Then it's going to go pin plus plus, which is make it 3, and it'll say 3 is less than 8, so pin 3 is an output. And then it'll go pin plus plus, and then it'll be 4. 4 is less than 8, so pin 4 is an output. And it'll keep doing that until it gets up to pin 7. And it'll say, yep, pin 7 is an output. And then it'll go pin plus plus, which would be 7 plus 1, which would be 8. And then it will say 8 is less than 8, false, and then it stops. So that for loop right there is done. Now here is this code has 2 more for loops in it that are almost identical. So well, we have one for loop right here that's going to turn, if you look at, you can see it's digital writing. It's turning an LED on, waiting for a certain amount of time, and then turning the LED off. And then we want it to go through all 6 pins. So start at pin 2, turn it on, then off. Pin 3 on, then off. Pin 4 on, then off, and so on. So we're doing basically the exact same thing that we're doing up here. So if you want, you can actually copy that. You can copy this pin thing here, everything that's inside the parentheses, and then you can put it down here in this for loop and replace those. Now the other classes we made one change to this, but I'm going to not do it this time and see if we can get it to work. Last time I messed it up because I forgot to put int, and then it didn't work. And I thought it was because that was a global variable, but I think these are treated as local variables. So then what I've done here is I'm doing the same thing. I'm just going through all the pins. And now for my variable here, this is going to also be pin. This is the number of the pin that I'm turning to high and low. And you want to make sure you get both of them. The one for high and one for low. Earlier today, I saw some people, they forgot to do the low one. And then it didn't work. They just put variable. And they left variable there and it didn't work. So that should be done. Ramsey, what are we changing statement 2? Statement 2 was the test. So that's this one here. We're basically saying, is the pin less than 8? Is the pin less than 8? And what we did, Ramsey, in case you didn't see it, is I copied my loop from void setup, or not the whole thing. I just copied what was inside the parentheses, and I put it in to this loop down here inside my void loop, because it's doing the exact same thing. And then these two variables that were here for my digital rights, I changed the word variable to pin, because pin is the name of my variable here. And I think that's going to work. I'm not 100% sure yet, but I think it will work. And then the last one is this last for loop. Now remember, the first for loop starts at pin 2 and it goes on off. Then it goes to pin 3, on off. Pin 4, on off. Pin 5, on off. Pin 6, on off. Pin 7, on off. Now I want it to go the other way, from pin 7 on off, 6 on off, 5 on off, and so on. So I'm going to be doing the exact opposite of this loop. And the way I can do that is just change the numbers around. So right here, this little int thing here, I'm going to copy that again, and I'm going to come down here to my last for loop, my 3 statements, and I'm going to paste it in there. But I have to do some changes. Okay, so my changes are going to be this. I'm actually, instead of starting at pin 2, I'm going to start at pin 7. So I'm going to make pin is equal to 7. And instead of pin being less than 8, I'm going to change it to pin more than 1, because 2 is going to be more than 1. That's my last pin. And then instead of incrementing it or using pin plus plus, I'm going to decrement it and use pin minus minus. And then because I'm using pin as my variable, I'm going to come down here and change variable to pin, variable to pin in both of them. And now the ultimate test, I want to see if this works, because I'm not sure if I can use pin for all of them. I know I can use it for these 2 loops, but I'm not sure if I can use it for setup and for the loop. So I'm going to start it and see if it works. And it works. Excellent. Okay. Anybody, if you're having any problems with that, I'm going to zoom my screen out just a tad so you can see the whole code at once. Anybody has any questions or problems with that, let me know in the chat. Or you can unmute yourself. And then once you're done with it, you're going to copy the whole thing, come back here to Google Classroom, and paste it into this document that just says code. And also, if you want to play around with this, you can, that number 100, that's our timer. If you wanted to change it, like say you wanted to go faster, instead of 50 or instead of 100, let's say, what if you put 75 in there? And now it goes a lot faster. If you wanted to go slower, what would happen if you put 500 in there? You can see now it's going a lot slower. And see, that's the benefit of using a variable. So instead of going to all these delays and typing in 500 2 times, I can just change it once right there. Anybody have any questions on that? You should have, here's my circuit again. In real life, there's the Arduino. Now, if you guys, if anybody, like you guys are having fun with this Arduino thing and you like programming this thing, I got this Arduino, this breadboard, and this entire box of sensors right here, all this stuff for like $38 on eBay. So if you wanted to, if you had 38 bucks laying around and you want to buy, you want to do this for fun at home, check out eBay. Anybody having problems? Once you're done, copy the code, stick it in Google Classroom, and turn it in. And then once you've turned it in, let's see, I got 248, so we got a couple minutes. You're free to go once you've turned it in. You know, I'll stick around if you have any questions about your grades or anything. If you want to bring your grade up at all, those of you who, if you don't know what your grade is, I can tell you what your grade is. Have a good weekend, Molly. You too, Amaya. Have a good weekend. Yes, Alina, it will save automatically. Now mine up here, it gives it some weird name, but you can change it. Like I can call this Night Rider, and it will save it in your Tinkercad. But and also this one, Andrew, you have a good weekend too, bud. It also this one also saves automatically, the code. You too, Alina. Thank you. Mikkel, are you doing okay in there, buddy? And Malcolm, actually, Malcolm, you're the other one. Malcolm, are you listening? Can you hear me? Malcolm. Malcolm. Mikkel. Okay, so Malcolm, okay, yeah, let me know if you need any help with that. You have a couple of missing assignments in there, and if you go in and knock out a few this weekend, same thing. Just look for the ones in Tinkercad, especially. Those seem to be the easiest ones to do. That'll bump your grade up because right now you're just a tiny bit below a C. Actually, the two you're missing are not in Tinkercad. Let's see, what are you missing? Actually, no, you are missing 2 Tinkercad assignments, Malcolm. The push button and then one of the functions. And that looks like it. And then you're missing 2 things. The Nearpod that we did early on, week 2. So you're missing 2 week 2 assignments. So if you get those done, that will bump up your grade. 66 right now, Malcolm. The D. But if you do like at least 2 more assignments, that would probably bump you up to a B. And then Mikkel, you're almost in the same situation. Mikkel, are you there? Mikkel. Mikkel, can you hear me? Mr. Pratt? Mr. Pratt, can you hear me? Mikkel, he's probably not there. Joey has left.